Hello everyone, today I'm going to talk about Newton's binomial series. First, I need to talk about the history of binomial series. The binomial series is an expansion of Maclaurin series. In 1654, a French mathematics Blaise Pascal found a triangle which represents the triangular area of the binomial coefficients. The Pascal's triangle can only apply to positive integers powers. In 1665, Isaac Newton discovered the binomial series can be applied as a formal power series during the study of area enclosed under certain curves. In Newton's binomial series, the power series of parenthesis 1 plus x parenthesis to the power n expand to the polynomial where the number of terms is infinite. However, Newton did not prove the theory. In Newton's binomial series, the common form is parenthesis 1 plus 1 n plus 1 terms, where n is the power, a and b are arbitrary number, and k is the number from 0 to n. For example, when a equal to 1, the Newton's binomial series could written as in Newton's binomial series, the common form is parenthesis a plus b to the power n equal to the sum of n choose k times a to the power n minus k times b to the power k. And where n is the power, a and b are the arbitrary numbers, and k is the number of from 0 to n. And the coefficient of binomial series is defined as n choose k, which we can write as like this form. There are certain examples. First one, for example, when a equal to 1, the Newton's binomial series could written as 1 plus x to the power n equal to the sum of n choose k times k to the power x to the power k. And a few other examples we can write as in different forms. There are a few properties of this series. The sum of coefficient n choose k equal to 2 to the power n. When you open it up, you will get n choose 0 plus n choose 1 plus n choose 2 all the way to n choose n. We can see from the graph on the top left, the first row we have 2 to the power 0, and the second row, when you add two numbers up, we will get 2 to the power 1, and the third line, we add all the numbers up, we will get 2 to the power 2, and the fourth line we will add all the numbers up, we will get 2 to the power 3. And the second series we can see from the top right graph, the sum of two by closed numbers are equal to the number between them in the next row. And the third properties we can see from the bottom left. The coefficient in the middle terms is always the maximum in the row, which is what we call the peak. And the fourth properties of the series we can see from the bottom right, where n choose k equal to n choose n minus k. The coefficient of series is symmetric distribution for the middle. Now we need to show you how to prove this series. First, we need to mention Taylor series. In Taylor series, any function related to x can expand as the Taylor series form. So in this proof, we will set f of b equal to a plus b to the power n for constant a and n. It is easy to see that a times derivative of f of b equal to n times n minus 1 all the way till n minus k plus 1 times a plus b to the power n minus k. We can expand this series in b equal to 0. Then we will have k times derivative of f of 0 equal to n times n minus 1 all the way till n minus k plus 1 times a to the power n minus k. So the Taylor series f of b for centered at 0 is a plus b to the power n equal to the sum of n times n minus 1 all the way till n minus k plus 1 times a to the power n minus k times b to the power k. Divide k factorial. And this whole thing, when we shrink it down, we will have what we call the Newton's binomial series. And this is the end of the proof.